tangent lines and normal lines worksheet. Let's go through this. So find the tangent and normal lines at the given point in the graph. So remember the way we're going to find tangent lines, the same way we've been doing it since like algebra 1. We want to find the equation of a line, y minus y1 equals m times x minus x1. Right? And I give you the point at A, so that's my x1. So it's 2. If you have the x1, how do you find the y1? Well, you just sub it into the function. So I get 4 times 3 is 12 plus 4, so 16. Now here's the key thing. How do you find m? M is so since we're trying to find the tangent line, right? So that makes this, so we're trying to find the tangent line. So this is the slope of the tangent line by definition. Remember what the slope of the tangent line is though? It's just a derivative at our a value, which in this case is 2. So we just got to find the derivative and then plug in 2. So let's take the derivative. That'll be 6x plus 2. Right, the derivative 3x squared is 6x, or 2x is just 2. And then we plug in 2. So we get 6 times 2 plus 2. So 12 plus 2 is 14. So my tangent line is just plug in 14. So we get y minus 16 equals 14x minus 2. There we go. Right? So your a1 is your x1. Sub it in to find your y1. To find the slope, that's the most important part. And on the AP exam, that's the only part they really give you credit for. You don't get a point for putting 2 and 16. It's algebra and stuff. For getting the correct slope, you do get a point though. So you take the derivative and then plug in your a1 to find the slope. So that's the tangent line. And then the normal line is a perpendicular line. So all you have to do there is flip the middle sign. Flip the slope. So y minus 16 equals negative 1 over 14 x minus 2. Right? Negative reciprocal slope. So there we go. I don't think I asked you to graph. Oh, and graph. We'll do a quick graph. So graph of 3x squared plus 2x. If I factor in x, I have at 0 and negative 2/3, I believe, are my x-intercepts. So it's kind of like this. It's not a fancy graph, it's a basic one. And then where's our tangent line at? It's at 2. So at 2, our tangent line. So it looks something like this. Oh, that's a bad tangent line. Maybe if I do it in a different color, it might be a little pop out a bit more. So like that's our tangent line, and then the normal line would be over here, perpendicular to that. It's supposed to be there we go. So there's our tangent line. Here's our tangent line. And this is the normal line. Okay. Next one, same idea. Alright, so we're going to go y minus y1 equals m x minus x1. We have our x1, we have 2. To find the y, we're going to plug it in. So that's 8. And then find the slope. That's the derivative at a. So let's take the derivative. 3x squared and tub in your 2. So 3 times 2 squared. So this is 4 times 3 is 12. So there's my tangent line. Y minus 8 equals 12 x minus 2. You notice again, I don't put in a slope intercept like that unless they specifically ask you, which in AP Calc they rarely do. So you just leave it like that. It makes normal line super easy. And my normal line would be y minus 8 equals negative 1 over 12 x minus 2. Done. If I want to graph this, again, we're just doing a quick sketch, nothing crazy. X cubed looks like this. It's kind of like a parabola where the other side goes down. And then at 2 again, we have a tangent line. It hit up to one spot, and then perpendicular line, the normal line. So something to that effect. Next one, more the same. So y minus y1 equals m x minus x1. 0 is our x1. F of 0 will give me my y1, which is just 0 cubed plus 0, so just 0. Remember, m is always ascending, it's a derivative. So this is always f prime of x1-ish. So f prime would be 3x squared plus 1. Plug in our a, so f prime was 0. So I just get 1 there. So I get y equals 1x. I like simplified everything. And that makes a normal line. Y equals negative 1 over 1x. That's fun. It looks a little bit like this. Again, we're not going crazy. It's an x cube graph, so we'll treat pretty much the same. It's a little bit funkier, but generally the same idea. Then we have a tangent line at 0. Now we have the negative 1x looks like this. So there we go, right? So this looks like y equals x, and that'll be y equals negative x. The next one, f of x equals x to negative 1, or 1 over x. 1 over x is easier for subbing it in, but if you're taking a derivative, it has to be this way. So for the step 1, my tangent line, y minus y1 equals m x minus x1. So a equals 3. F of 3, which would be 1 over 3. Done. Remember the derivative m for my derivative? I need to take a derivative of this guy, so you take a derivative of this one. F prime of x is equal, bring it down, subtract 1 off. Negative 1 x to negative 2. And I'm going to plug 3 in, so f prime of 3. Negative 1, 3 to negative 2, which means I got to flip it. So it's negative 1 over 3 squared, which is negative 1 over 9. So that's my slope. Y equals, y minus 1/3 equals negative 1/9 x minus 3. That's my tangent line. Normal line, all we do is flip and change. Negative reciprocal of the slope. So we're going to flip it and change the sign. And you just get 9. Now if I want you to graph it, again, just a sketch. 1 over x is a reciprocal function. Looks kind of like this. Not my best, but something to this effect. And then at 3, 1, 2, 3. So we have a tangent line. And we have a normal line. So in sound effects. More of the same. This time we just want the tangent line. So y minus y1 equals m x minus x1. My a is negative 2. Done. F of negative 2. 1 over negative 2 plus 3, which is 1 over 1, so just 1. Remember to find m, that's the derivative at a. So we gotta take a derivative of this guy. But look at that guy. It's a quotient rule. So let's do the quotient rule. F prime of x, right? For a quotient rule, derivative of the top times the bottom minus derivative of the bottom times the top, all over the bottom squared. So the derivative of the top is 0 times the bottom minus the derivative of the bottom, which is just 1, times the top 1, all over the bottom squared. So the derivative equals negative 1 over x plus 3 squared. Right, that's just 0, and that's just 1. Now that's good. Always remember, that should not, don't ever put like this as your m. That's not your m. Your m is at a certain value. So we're going to type in negative 2. Sub in negative 2. So negative 1 over negative 2 plus 3 squared. So negative 1 over 1 squared. So negative 1. So m is negative 1. So there we go. Another one, 34, 37, 34 first. Ha. So let's do this one real quick. It looks like another one that's going to be ugly. The good news, they gave us our a and our point. So for my equation here, we have that part done. You got 3 and 2. But the derivative, much like last time, is going to be a quotient rule. So f prime of x equals the derivative of the top is 1 times the bottom left alone. Minus the derivative of the bottom, which is 1 times the top left alone. all over the bottom squared. Simplify that just a little bit. X minus 1 minus x minus 1. X minus 1 squared. That's going to get me negative 2 over x minus 1 squared. And then we got to plug in 3. So negative 2 over 3 minus 1 squared. Negative 2 over 4, so negative 1/2. So my answer is y minus 2 equals negative 1/2 x minus 3. Let's go back up to 37. A little easier. Right, so y minus y1 equals m x minus x1. So again, I have my x1. If you want to find your y1, you have to sub it in. 1 to the power is 1, so that's easy. The key thing is always m. That's the key, right? So remember, take the derivative and plug your x in. So my derivative here, bring it down, subtract 1 off, is negative 3 t to the negative 4. The good news, we're just plugging in 1, so negative 3, 1 to negative 4, or just negative 3. So there's my tangent line. Y minus 1 equals negative 3 x minus 1. 39. So, I gotta find tangent line again. Right, we know it's gonna be y minus y1 equals m x minus x1. And we know x1 is 9. So to find y1, just sub it in. 1 over square root of 9, so that's gonna be 1 over 3. Now m, as always, that's the derivative at x1. So let's take a derivative. Actually, before I take a derivative, because I don't get people confused, we gotta rewrite it first. So f of x equals 1 over x to the 1/2, which equals, gotta flip it up, x to the negative 1/2. So remember, that's not the derivative yet. We just rewrote it. This is algebra. So a lot of times I always get people get here and they're like, okay, done. Plug in the 3 and be done with it. We just rewrote it. So now let's take a derivative. F prime of x, bring that down, subtract 1 off. Negative 1/2 x, common denominator, negative 3 over 2. So that's my derivative. Now we got sub in 9. So f prime of 9 equals negative 1/2, 9 to the negative 3/2. Now don't forget about that. We just got to simplify this, right? First, it's a negative, so let's flip it. Negative 1/2 times 1 over 9 to the 3/2. Right? You just flip it, nothing else changes. Now the way you do 9 to the 3/2, you always want to do the root first, make it smaller. What's the square root of 9? 3. Now what's 3 cubed? 27. This is negative 1 over half times 1 over 27, which gets us negative 1 over 54. That is our slope. So my tangent line is going to be y minus 1/3 equals negative 1 over 54 x minus 9. Remember, if I wanted a normal line, all I gotta do is flip this to 54 and then have a normal line. Okay, next. What's the equation of a tangent line at x equals 3, assuming f of 3 equals 5 and f prime of 3 equals 2? So this is the easiest question in the world if you understand what's going on. So let's do this. Right, that's the equation of my tangent line. Look what it's asking you. At x equals 3. Okay, there's my x1. What's my y1? Well, right here. When you type in x, you got 5. So my y1's 5. Okay, what's my m? That's the derivative at x1, right? Well, they tell you that. It's 2. Oh, there's my m. So my problem's done? Yeah. So there you go. Next one. Suppose that y equals 5 over x. Y equals 5x plus 2 is an equation of the tangent line to the graph of y equals f of x at x equals 3. What's f of 3 and f prime of 3? Okay, this is a little more interesting. So y equals 5x plus 2 is an equation of the tangent line. And they want to know what f of 3 is and f prime of 3 is. Okay. So f prime of 3 is the easiest one. This is a tan line. This guy is a tan line. So what's f prime of 3? That's the slope of the tan line. That's what derivative is. So what's the slope of my tan line? 5. Done. That's the easy one, right? That's the tan line. The derivative is the slope of the tan line. So what's the slope of this tan line? 5 is, because I'm supposed to be. Okay, how about I put 3? Well, here's the thing. Maybe we didn't notice up here, but if you plug in your x into this, like, the whole idea of these graphs here is that they cross that, there we go, they cross that one point. So when you plug in 3 into the normal equation, into the tan line equation, or into the normal line, you're going to get the same y. So if we go back to our problem here, I know what the x is, I want to figure out the y is, you just plug it into the tan line equation. So my f of 3 is just going to be 5 times 3 plus 2. So 15 plus 2, 17. That is it. Right, so if you want to find the x, plug it into the equation, find the y. If you want to find the slope, it's the slope of the tan line. Last problem. Consider the curve y equals 2x, y equals, that's why curves in parentheses, in quotation, sorry. I'm a math brain. Y equals 2x plus 8. What is the tangent line at the point 110? Describe the tangent line at any arbitrary point. Well, let's look at this graph here. Right, y equals 2x plus 8. That's our curve right there. Describe the tangent line at this point. Well, this is a linear line, right? It is a tangent line to itself, basically. So the tangent line is going to be the exact same thing because it's linear. It's always going to be that. That's all it's ever going to be. And that's the worksheet.